Welcome to The Explainer. So today, we are diving into a really wild, fascinating question. What if humans actually lived on Mars? Like, is it really possible or just sci-fi fantasy? To figure this out, we're going to try something fun. We're going to treat this ultimate Mars survival guide as if we're feeding prompts into an incredibly advanced AI video generator to understand if it's actually possible or not. Let's see what exact parameters we'd literally have to punch in to visualize a truly scientifically accurate Martian colony.
Now, to understand this approach, let's look at how cutting-edge AI video tools actually work. Platforms like Kling AI and Mushin are absolute game changers. They let creators generate high-definition story beats and visual physics in just minutes. You type in a prompt, and the AI acts as your digital storyboard, instantly stress-testing your script through visual motion and environmental physics. It's the super rapid loop of generating, revising, and validating, and we are going to use this exact concept as a strict validation layer for our hypothetical Martian colony.
Okay, let's dive into this. If we want to generate an authentic, biologically survivable Martian simulation, a storyline where humans don't just land but actually survive and thrive, what do we absolutely need to put into our prompt? What are the actual stakes here? Because I'll tell you right now, if we don't get the science exactly right, our digital colonists are not going to make it past the very first scene.
Imagine this. If our first AI render just showed humans casually standing on the surface in regular spacesuits, it would immediately fail a scientific reality check. Just look at the massive contrast here. On Earth, we're spoiled. We enjoy perfect atmospheric pressure at sea level and a robust magnetic shield. But Mars? Mars has an atmospheric pressure of around 600 pascals. That is less than 1% of Earth's density. Add to that an extreme average cold of -46 degrees Celsius and a constant, deadly bombardment of galactic cosmic rays. Simply put, the surface is completely inhospitable.
And that brings us to Act I of our storyboard, setting the scene. To make our simulation even remotely survivable, we have to prompt our 3D models to build underground. Subsurface habitats are an absolute necessity. There's no way around it. By building several meters below the surface, we use the Martian crust, the regolith, for innate radiation shielding and thermal insulation. This naturally traps heat and protects our colonists from the cosmic radiation that would literally cause severe cellular damage if they stayed above ground.
But hold on, how do we actually build these massive underground cities? We can't exactly order heavy bricks and ship them from Earth, right? We have to live off the land. Check out this extraction process for Martian concrete. It's brilliant. First, we gather the native regolith, which is mostly just weathered basalt and dust. Then we extract sulfur, which is everywhere on Mars, and heat it up until it melts. By mixing that liquid sulfur directly with the regolith and letting it cool, it forms a concrete with a compressive strength that's entirely on par with what we use right here on Earth.
Now, what's really interesting about this slide is the logistical reality of just keeping our colony's lights on. It presents a massive, fascinating challenge. We need a rock-solid energy grid. We could prompt for solar power, which sounds great because there's abundant surface light, but Martian dust storms can severely choke its efficiency. Geothermal is another option, tapping into the planet's internal heat flux, but that requires advanced drilling tech we'd literally have to invent first. Finally, nuclear fission provides incredible, reliable, high-density, baseline power, but it requires shipping incredibly heavy materials millions of miles from Earth. So our AI prompt has to balance these trade-offs perfectly.
122 grams. I really want you to let that number sink in. That number is a massive, massive triumph for human engineering. This is the exact amount of oxygen that NASA's MOXIE experiment successfully generated directly on the surface of Mars while riding aboard the Perseverance rover. To put that into perspective, 122 grams is roughly what a small dog breathes in about 10 hours. It might sound like a tiny amount, but it definitively proves that generating breathable air on Mars isn't just a fun sci-fi theory anymore, it's actual reality.
Let's break down exactly how MOXIE pulled this whole thing off. Over a full Martian year, it completed 16 separate runs. It uses an electrochemical process to literally tear oxygen atoms away from the carbon dioxide in Mars's super-thin atmosphere. It hit a max rate of 12 grams an hour at 98% purity. This kind of data securely grounds our sci-fi storyboard in real hard NASA science. It proves, without a doubt, that future astronauts can utilize local resources, not just to breathe, but to manufacture the massive industrial quantities of liquid oxygen they're going to need as rocket propellant just to get back home.
Okay, so we've got concrete, we've got power, and we've got oxygen. Awesome. Now let's move to Act II, the character arc. We really need to shift the narrative to our actors, the human crew. Because, as it turns out, surviving the physical environment is only half the battle. Our crew is going to face a massive, unprecedented genetic and epigenetic mismatch. Simply put, human biology and human psychology evolved right here on Earth, not in the deep, freezing, isolated abyss of space.
As you can see from this peer-reviewed journal cover from Acta Astronautica, the academic credibility behind these psychological challenges is incredibly heavy. Physical health countermeasures, like intense daily exercise to prevent your bones and muscles from wasting away, are super well documented. But the psychological and biological hurdles of profound, deep space isolation, that is where the true terrifying risks lie. If our AI render completely ignores the human mind, our colony is going to collapse from the inside out.
And this brilliantly illustrates exactly what we need to do. To prevent that collapse, we have to meticulously program our crew's routine. We're talking about adapting Maslow's hierarchy of needs specifically for deep space. Physiologically, sure, we mitigate radiation and atrophy. But look closely at the security and relationship needs. We have to engineer the mission design to absolutely prevent interpersonal conflicts, confinement-induced violence, or even mass psychogenic illness where weird aberrant behaviors spread rapidly through the isolated crew. And finally, existential needs. The crew absolutely must have a profound sense of purpose to stave off severe depression.
Now, one of the absolute most chilling realities our colonists are going to face is something called the Earth out of view phenomenon. This is an unprecedented psychological stressor. On the International Space Station, astronauts can just float over to a window and see beautiful Earth passing right below them. But on Mars, at up to 140 million miles away, Earth is just another tiny pale dot in the night sky. Experiencing that extreme separation from our terrestrial home can trigger severe separation anxiety and deep, dark existential crises. It's a stressor we've honestly never truly replicated in terrestrial analog missions.
And compounding that immense isolation is another critical number: 4 to 24 minutes. That is the one-way communication delay to Earth, entirely depending on planetary alignment. Think about what that actually means. If a psychological crisis suddenly occurs, or a vital piece of life support machinery breaks, the crew literally cannot wait for ground control to respond. They can't just pick up the phone. They must be entirely 100% self-sufficient in every emergency. They are truly out there on their own.
So how in the world do we counter this intense psychological strain? Well, we have to implement biophilia directly into our colony's prompt. Biophilia is basically the innate human tendency to seek out nature and other forms of life. Studies consistently show that viewing natural scenery and interacting with green plants significantly decreases fear arousal and physiological anxiety. So bringing Earth's biology to Mars isn't just some cute aesthetic choice to make the base look pretty, it is an absolute biological necessity to keep the crew completely sane.
When you think of spaceships or off-world colonies in big Hollywood movies, what do you usually picture? Probably cold, sterile, entirely mechanical living quarters, right? But the scientific reality of a functional Mars colony is going to look very, very different. These habitats will literally need to be filled with flowering plants, aeroponics, and massive algae bioreactors. These bioreactors consume carbon dioxide and pump out fresh oxygen, sure, but they also serve a crucial secondary purpose: psychologically grounding the crew by surrounding them with the warm, familiar, living green of Earth.
And we can't forget about sound. In AI video platforms like Motion, there's this incredible feature called Native Audio Sync, which basically generates realistic acoustic physics that move in perfect harmony with the visual story. Well, on Mars, we have to artificially engineer this exact concept for our crew. They have a deep, ingrained psychological need for familiar soundscapes, like the gentle, steady hum of an engine, or even simulated cosmic winds, just to prevent complete sensory deprivation in the absolute dead silence of an underground bunker.
All right, let's move to Act 3, the grand finale of our storyboard. Let's say we survive the underground bunkers. Can we eventually move up to the surface? Can we render a fully terraformed, lush, green, Earth-like Mars where we can just walk outside without a bulky spacesuit? Let's check the scientific parameters for true planetary engineering.
The classic terraforming dream basically involves releasing massive amounts of greenhouse gases to crank up the atmospheric pressure and warm the planet. But here is a harsh reality check. A major 2018 NASA report concluded that the required resources simply do not currently exist on Mars. There just isn't enough accessible carbon dioxide available on the entire planet to create a dense, warm Earth-like atmosphere. So for now anyway, a fully terraformed Earth twin is just way beyond our reach.
But hey, science is always evolving, right?
A super recent 2024 study by MIT suggests that the remains of a massive, ancient Martian atmosphere might actually be hidden, literally locked away in the clay right there on the planet's surface. So, while we definitely can't terraform Mars today, ongoing scientific discoveries like this might eventually unlock the massive resources we need for true planet-wide engineering.
So the crucial point is this. Our long-term survival on Mars absolutely cannot depend on an endless, incredibly expensive supply chain from Earth. As highlighted by the Towards Sustainable Horizons study, true sustainability relies 100% on our ability to utilize exactly what Mars provides. We must transform Martian raw materials into our homes, our breathable air, and our rocket fuel. That's the only way this works.
So, let's review the final validation checklist for our AI render of a scientifically accurate Martian colony. To get a successful output without our digital colonists perishing, we need high-fidelity subsurface shielding using that native Martian concrete. We need MOXIE-style generators aggressively pulling oxygen from the atmosphere. We must have biophilic design and algae bioreactors fully integrated to keep the air clean and the crew psychologically grounded. And finally, we need highly trained, autonomous, psychologically resilient crews who can handle extreme isolation.
We really do have the technological blueprints right now. We can absolutely engineer the concrete, we can extract the oxygen, and we can heat those underground habitats. But it leaves us with one final, profound question. Can we truly engineer the human mind to thrive in the abyss? Perhaps human psychology, more than any massive rocket or advanced radiation shield, is the true final, unconquered frontier of space exploration. Thank you so much for joining me on this explainer. I really hope this gave you a whole new perspective on what it will genuinely take to survive on the Red Planet.